Okay, let's do a series and parallel resistance lab in every circuit. If you don't know how to do a lab, make sure to watch the video on how to get every circuit and how to actually manipulate around it. All right, so I've got this right here from one of the previous videos. What I'm going to do is I'm going to stop this. Let's go back. I'm going to click that left arrow to go back into the circuits I've built. And what we're going to do is we're going to click the little plus paper sign, the third from the right up on the top right. So that right there is going to give us our ground symbol. We're going to drag that ground symbol down. We're going to add a voltage source, like a DC voltage source. And then what we're going to do is we're going to add like that. Let's put that over there. Like a Christmas tree. Okay. All right. So what I'd like you to do is touch one of the nodes, like let's touch the top node of the voltage source, and then go up there to the top node there. And then what we're going to do is we're going to make that connection there. So that node is going to be connected to 3 resistors. So hit the nodes on those 3 resistors. This one's going to be connected. I hate how that looks. So if you touch the wire, I'm gonna cut that and see if I can't get it. Man, that stinks right there. All right, so I'll cut that. I'll cut that. Then I'm gonna go over here, and then I'm gonna hit that. Come on now. I wanted a Christmas tree. Used to could drag those down. Oh well. Doesn't matter what the wire's doing. We got a funky Christmas tree now. All right, so then I'm gonna go over there, the bottom of that resistor, and then I'm going to take the ground and connect it there. All right, so I don't care how it looks as long as the connections are there. All right, once you do that, go ahead and let's do a good round number. Let's do a big, good round number. So let's change that voltage source to 1,000. So you click on the component, then you click on the little wrench, and then you get a little wheel over here, and you're going to turn it until you get to 1,000 or 1 kV. All right, so I want the math to be pretty easy for us to think about. So I've got one circuit, or one part of the circuit down toward the bottom that has 3 things in it. I've got part of the circuit that's got 2 things in it. So just so that we don't have to, deal with weird numbers or whatever, let's find something that, common denominator type. So let's go with maybe 600. Okay. So For this one, let's change it to crud. For this one, let's change that to 600. For these two, let's change it to 1200. So 1.2K. So 1, and then you're going to have to take that and change it to 1.2. All right, and we're going to do the same here. So that's a 1K. Like if I scroll on the actual numbers, it goes up quicker. If I scroll with the arrow, it goes up slower. If I push the plus and minus, it goes up by 1. So I can really zoom in on that. All right, so 1200. All right, or yeah. And then what would it take 3 of if we're talking parallel to get to 600? You don't have to know this if you haven't had something know this. I'm just thinking out loud. It'll be 1800, so 1.8. So let's put those at 1.8. All right, so those 3 are going to be 1.8. And then since we've got 1 again, we're going to put that back down to 600 like the top one. So everything should be kind of balanced. Let's go ahead and see what's going on there. Okay, so let's see if I can get this to, okay. All right, so right here we've got 250 volts. Across here we got 500 volts. Across here we got 750. And then between the ground and the top we got the 1000 volts that we had put the voltage source on. All right, so every step is 250. So it's equal distance. Like every network of the resistor is dropping the same amount. Okay. Now, we'll talk more about this where there's some things that should be pretty intuitive if you look at this and think about it. I don't want to waste your opportunity to have a light bulb moment. I'll explain it. But what I want you to do is study what's going on. Like we got 417 milliamps going in, 417 milliamps going out. What is 208 plus 208? That's 416, but you know, there's some fudging with the numbers. Like it should be equal. Okay, like when you're getting into simulation and dealing with milliamps, like the math can get kind of funky when you're, you know, dealing with decimal points. So what I would like to do, let's pause that and let's hit that 1K and let's take it up to maybe 10K. That might, yeah, that might actually help us, you know, with some whole numbers maybe. So take it's still doing a little bit of rounding error, but if it's within, you know, a couple milliamps, you can assume that it's the same. So you got a certain amount of volt or current going in, and then it divides You add all those up, it's the same amount of current, and then it combines back together, go through those two, and then it combines back together from those two and goes through the last one. All right, so I want you to build this, and I want you to what I'd like you to do is take a screenshot of it. So screenshot it. You're going to upload that. But as opposed to putting in the videos, what I want you to do with it, I think it'll be better to put it into the modules, because once I get these videos good, this one's not good, but once I get them to where I want them, it'll be better for me not to tell you on the video what to do with it, but to tell you whenever I give you the modules, because it might change, or you might have a different teacher who I'm the one doing these, and they want you to turn it in a certain way. So more than likely, you'll probably want to do a screenshot, but your assignment that this video would be in will tell you how to get credit for it. So if in 10 years I'm not here anymore, gone on to heaven or something, whoever is using my videos can change up how they want to have that turned in. So in the module it'll tell you, more than likely it'll probably be, especially this year, screenshot. All right, y'all have a good one.